Kubernetes and GKE Part 16. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. A pod is created via Kubernetes server. Here's a strong way to approach it. 2. The pod has no node assigned. 3. Kubescheduler watches for such pods. 4. It evaluates all available nodes. 5. It selects the best node. 6. It writes the decision back via the API server scheduling process. 2 phases. 1. Filtering. Predicates. Removes nodes that are not eligible. Not enough CPU or memory node selectors. Mismatch taints not tolerated. Node is unschedulable. 2. Scoring. Priorities. Ranks remaining nodes based on resource availability, CPU, memory, affinity or anti-affinity rules. Load balancing. Custom scheduling policies. The highest scoring node is selected. Factors considered during scheduling: CPU and memory requests. Node labels. Pod affinity or anti-affinity rules. Taints and tolerations. Volume constraints. Storage binding. Topology constraints. Zone or region spread. Example scenario: if you deploy a pod requiring 2 CPU, 4 GB RAM, the scheduler excludes nodes without enough resources, chooses a node with optimal capacity and balance, assigns the pod to that node. Key characteristics: stateless component, continuously watches for unscheduled pods. Pluggable, supports custom schedulers, can be extended with scheduling policies. Scheduler versus other components. Component role: Kubescheduler decides where pod runs. Kubelet actually runs the pod. Kubernetes server receives and stores requests. Stores cluster state. Interview ready definition: the kubescheduler is a Kubernetes control plane component that watches for unscheduled pods and assigns them to appropriate nodes based on resource requirements, policies, and constraints like affinity, taints, and available capacity. Nice. Let's continue. Question 2. Explain Kubecontroller Manager. Here's a strong way to approach it. The Kubecontroller Manager is a core component of Kubernetes that runs controller loops to ensure the cluster's actual state continuously matches the desired state. Core idea: it is the reconciliation engine of Kubernetes. If something drifts from the desired state, controllers inside this component fix it automatically. What it does: the Kubecontroller Manager runs multiple controllers, each responsible for a specific part of the system. Key controllers inside it: 1. Node controller monitors node health, marks nodes as not ready if they stop responding, evicts pods from unhealthy nodes. 2. Replication controller or replica set controller ensures the correct number of pod replicas are running. If a pod dies, creates a new one. 3. Deployment controller handles rollout and updates of deployments, manages replica sets behind the scenes. 4. Job controller ensures jobs complete successfully, restarts failed pods if needed. 5. Endpoint controller updates service endpoints when pods change. 6. Service account and token controller manages default service accounts and access tokens. How it works: loop model: each controller runs a loop. 1. Watch current state via Kubernetes API. 2. Compare with desired state. 3. Take corrective action if mismatch exists. This is called the control loop or reconciliation loop. Example scenario: if a deployment says run 3 replicas of nginx but only 2 are running, controller detects mismatch, creates 1 new pod, restores desired state. 3 pods. Relationship with other components. Component role: Kubernetes server entry point for cluster. Stores cluster state. Kubescheduler assigns pods to nodes. Kubecontroller Manager maintains desired state. Kubelet runs containers on nodes. Key characteristics: runs multiple controllers in a single process. Stateless state is stored in et. Continuously watches cluster via API server, ensures self-healing behavior. Interview ready definition: the Kubecontroller Manager is a Kubernetes control plane component that runs multiple controllers, responsible for continuously reconciling the cluster state with the desired state by monitoring resources and performing corrective actions like creating or deleting pods, updating endpoints, and managing node health. Great. Moving on. Question 3. What is kubelet? Here's a strong way to approach it. The kubelet is the primary node-level agent in Kubernetes that runs on every worker node and is responsible for making sure containers inside pods are running as expected. Core idea: if Kubernetes decides what should run, kubelet ensures it is actually running on the node. It is the bridge between the control plane and the container runtime. What kubelet does: 1. Pod execution: receives pod specs from the API server, ensures containers are created and running. 2. Container health monitoring: continuously checks container status, restarts containers if they fail, based on restart policy. 3. Node registration registers the node with the cluster, reports node health and resource usage. 4. Volume management mounts and unmounts storage volumes for pods. 5. Status reporting sends pod and node status back to the API server. How it works. Flow. 1. Pod is scheduled on a node by kubescheduler. 2. API server sends pod spec to the node. 3. Kubelet on that node receives the spec. 4. Kubelet instructs the container runtime, Docker or containered. 5. Containers are created and managed. 6. Kubelet monitors and reports status continuously. Kubelet versus container runtime. Kubelet equals orchestrator agent, container runtime, e.g. containered, equals executes containers. Kubelet tells the runtime what to run. Key responsibilities summary: run pods on the node, monitor and restart containers, report node or pod status, manage storage and networking setup for pods. Important characteristics: runs on every worker node, communicates with API server, does not make scheduling decisions, is essential for node operation. Interview ready definition: the kubelet is a node level agent in Kubernetes that runs on each worker node and ensures that the containers defined in pod specifications are running and healthy by interacting with the container runtime and reporting status back to the control plane. Alright, next question. Question 4. Explain kubeproxy. Here's a strong way to approach it. Kubeproxy is a node-level networking component in Kubernetes that enables network communication to services by routing traffic to the correct pod's core idea. Kubeproxy makes Kubernetes services actually work by forwarding traffic from a service IP to backend pod IPs. Why it exists: pods are ephemeral. They can come and go, so their IPs change. Kubeproxy solves this by providing a stable virtual IP, service IP, and handling routing behind the scenes. What Kubeproxy does: 1. Watches services and endpoints continuously, monitors the API server, tracks services, cluster IP, pod endpoints. 2. Programs networking rules on the node depending on mode. It creates rules using iptables. Most common: IPVS, high performance mode, user space mode, legacy. 3. Load balances traffic, distributes requests across healthy pods, performs simple round robin or hashing depending on mode. Traffic flow example: when a client hits a service, 1. Client sends request to service IP. 2. Kubeproxy rules intercept it. 3. Traffic is redirected to one of the backend pods. 4. Response is returned to client. Example: if a service has 3 pods, pod A, pod B, pod C. Kubeproxy ensures requests to service distributed across A, B, C modes of Kubeproxy. 1. Iptables mode. Default. Uses Linux iptables rules, fast and widely used. 2. IPVS mode, kernel-based load balancing, better performance at scale. 3. User space mode. Legacy. Old implementation. Rarely used today. Key responsibilities: implements service networking, maintains routing rules, enables load balancing, ensures service discovery, works internally. What Kubeproxy is not: it does not run containers, it does not schedule pods, it does not create services, it only handles network routing logic on nodes. Interview ready definition: Kubeproxy is a Kubernetes node agent that maintains network rules on each node. 2. Enable communication to services by forwarding and load balancing traffic from a service IP to the appropriate backend pods. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.